This is the graphical user interface that we're going to program together in Python, and we're going to use the Tkinter module to do it with. So what I wanted to do was treat this kind of like a wireframe design and take you through what you're looking at so that you'll be able to link it up to your program in a wee second. Right, so what we've got here is a graphical user interface, and this is where you find this GUI for short, and you pronounce it GUI. So this is a GUI, a graphical user interface. Now, we call this a window, don't we? And you're used to seeing that in Microsoft's operating system. They actually call it Windows. And each window has got window controls. And you're used to this one here, which is the minimize control, the maximize control, and the close. To close a program which has a user interface, you need to do this. You need to press the X to close it. Now over here, this window has got a title, and it's also got a bitmap icon. You've probably seen an ICO file, .ico. That's what that thing is there. So you can personalize it. Now, in Python, this Tkinter module, let me write that in, Tkinter. Some people call it Tkinter. It just depends. I call it Tkinter because it is separate. Now, this module it's been written in an object-orientated programming fashion, which means this, when you create this, you're creating an instance of the class TK, and you'll see how to do that in programming in a wee minute, which means that these things here are properties of the class, and you have to set them using the dot notation. So those are things to consider when you're looking at this, because it is new to you. Right, so what we've got here is we've got frames. We've got two frames. Wonder if you can identify them. So here's frame 1 and here is frame 2. And the frames are used to visually place objects inside. And inside, the frame has got a title. This top frame here is decimal to 8-bit binary, and the bottom frame is 8-bit binary to decimal. So it's quite clear to the user. It's giving them some feedback, and it's orientating them to your interface, which is really important that the user can understand how to use it very quickly. Now we can see here there's a couple of labels, and you can tell that they're labels because they're following the kind of standard notation of the name plus your colon. We've got a couple of buttons. Yeah, there's another one. Now, the way it's written, there's kind of 3 steps to this. There's step 1, there's step 2, and there's step 3. And the user can see that. They can see that reading from left to right. First of all, okay, this is the decimal to binary conversion. That means I need to put a number in here. And this is your classic input box. And in Tkinter, it's called entry. And it allows you to enter 1 line of text. Then you would click the button, which would call the method into action, and here is your output. So you still have this input, process, output that you're used to. It's just that now you have to visually create that input, process and output so that whoever is using this program can use it correctly. To help with that, these here, I know they might look like entry boxes, text boxes, because they've got a white background, but in actual fact those are labels as well. So the user can't input into this. This is a read only. So you're controlling what the user can do. Same down here, this is a label. Now the user can enter in here and they can delete before they click the button, and then the answer appears. Because this says 8-bit, that means there is a range from 0 to 255 decimal. So base 10 can be expressed in 8 bits. So that means there needs to be some sort of validation on here to control the user that they can't put in here 256. And we'll find out how to do that in the program. So you might want to take a screenshot of this, and as we're working through the program, refer back to it so you can orientate yourself to where you are. Here's the program running. You can see that the cursor is flashing in the text box. That's giving the user some feedback to say enter text here, and it's telling them decimal. The label is saying decimal, so the user should put in a decimal number. And because it's an 8-bit, it needs to be between 0 and 255. So if I try and put in another number here, it's just going to keep flashing away there. It's not going to allow it. And we'll create that with validation. Then we click the convert button, and the binary output is an 8-bit representation of 56s, 00111 Now you can see that the cursor is now flashing down here, so it's letting the user know that you can come down here now and you can click into this area, and this time it's the reverse. It's an 8-bit binary to decimal, so we want to put in our 8 bits. Now we've got 8 here, so wouldn't it be quite good if we tested this to make sure if it's correct? Just type in 00111 click the convert button, and you'll get your answer 56. Now you can put another one in here, so the user can go back and edit this and then convert, and it's up to 57. We could put one in here, and that would be 59 because we've just added a 2 to it, and if we add a 4 to that, that should be 63. So that seems to be working okay. The user can come back in here, they can backspace to delete that. We can put in here 255 and convert it, and immediately, straight away, you've got your 8 bits. If we take one off of that, 254, we're allowed to do that and convert it immediately. But if we will try to do 256, it just won't allow it. I'm pressing and it just won't allow it. But I can put in 250, convert that. And let's check to make sure that is 250, so we can highlight that. So it's 111010 and convert that, and it's 250. So that seems to be working okay. I'm using Thorny. You can use Visual Studio Code if you want. So let's get started. First thing we want to do is put in the modules that we're going to need. So we want from Tkinter import all, and we want to import regular expressions, and I'll explain that when we get to it. And we also want to import the Tkinter dot font, and we're going to call it font, so that we can style the interface. Now we will start with the interface. We will come back and put in the program sub-programs that we've created earlier without an interface. So what we want to do next, once we've got our modules, we want to instantiate the object. So we want to create an instance of the class Tkinter, and to do that we define a variable to create it as. So you can either call it whatever you want really. You can either GUI or root. I'm going to go for root because root in program kind of means the base, where it starts from. So this is what we want here. So root, and it's a capital T, K, and the brackets are calling that method into operation. So I'm just going to put a I'm just going to put a comment in here to say that we have created an instance of the class TK, and we've created an object root. Right, now remember I said that because it's this object orientated programming, the objects have properties and methods. So one of the properties of the window that you saw was the title. So we're going to say root dot, using this dot notation, title, and inside brackets we're going to put the title. So you need your speech marks for this because it's text, and we'll call it number system converter. And we can we'll save it in a wee minute, because there's one thing that needs to be added to the very bottom of a Python program that's using Tkinter user interface, and that is to create this continuous loop. So it's root dot main loop. So what you're doing there is you're creating a continual loop, and this program will continue to loop so that the user will continue to see the user interface, and every time the user interacts with the interface, the program code, because it's been continually looped through, it's listening for interactions, it's listening for events occurring, like the user typing into the entry box, and it will handle it. So we can save this now, Control S. Now I've saved mine as number system converter with GUI. You can save it whatever you want to call it, and then press play. And what happens here is it doesn't look like much. Let me just see if I can drag it into the actual... Right, there we are. I don't know if you can see. There we are, finally. So there you go, number system converter. Now you see how that started off as a wee tiny thing like that? It's because we've got nothing inside it. Tkinter works differently from what you're used to with your HTML programming, where you define things and it stays that size, etc. This is different, but it's interesting, and it's worth spending a wee bit of time just to get used to it. So we've got our first thing, we've created our object, we've called it root, and we've set the title property to number system converter. Now you can see this icon here is the Tkinter icon. If you've created an icon file, you can use it. It might be something that I do later on, is put up a video to show you how to do that. If you would like it, you can let me know. Right, so what we want to do now is I'm going to put mine up just so that you can see how it would work. And again, it's another, so I'm going to close that, because remember I said to stop the program. Now, because I'm running it in Thorny, I can press stop here to stop it, but this stops it as well. Right, so let's put in this next thing. So it's root.icon bitmap. So that's the property. And I'm going to set it to the path at the moment that I know that I'll be able to find the icon I made. But you can make your own icon and add it in. It's great fun. Oops, well that's not. Right, so my path, it won't be the same for you, and this is the absolute path at the moment, which is not ideal, but I'll just do it. And you're getting to know my file system. And it's got this ICO file type, so I'm going to save that and run this program again to see if it's picked it up okay. And if I can drag that out of there we are. Okay, so I'll move it in here so that you can see it, and you can see now there is my icon logo, number system converter. And the thing about an icon is, just to go off piste a wee minute, you have to make it so that it's not too busy, because you're saving it to such a small size, and you save a range of them, and the operating system picks which one is best Okay, so enough of that. We'll do that at a later date. Right, let's add another property, this time the geometry property, which is used for setting up the dimensions of the outside window. So I'm going to set it to be 700 times 450. Now it's not pixels, it's a strange unit of measurement, and it's a unit of text. Sorry, it's a character size, so it's the width of a character, so that means 700 characters, and that means 450 heights of characters. Obviously it depends on what font, so that's one of the things about a Tkinter interface. It moves about a bit depending on what you set. Right, so here it is. So that's 700 characters by 450 characters high, and we've still got a logo and things. Good, it's all going well. Right, next thing we want to do is we want to actually get a couple of frames in, don't we? So let's do that. Now we'll just define the frame. So I'm going to put in a section header to say this. So frame 1 defined, and we'll just do frame 1 and see how we got on with it. So I'm going to call it frame 1. So I've created a variable here called frame 1, and I'm going to assign it. Now see, I'm using a capital letter there. That's because this is another class, label frame. It's a child of the TK class, but it is a class. And what I'm doing now here, because I'm using these brackets, this is me instantiating, this is me creating an instance of this class, and the instance that I've created is called frame1, and when I want to refer to this class I need to call it frame1, and if I want to set the properties of it I need to use that dot notation. So when I'm setting it for the first time, instantiating it, I need to say where it lives, who its parent is. In this instance our parent is called root, so we put in root, comma, and then text that we want to have displayed. Remember there was a label in the wireframe design, so it's decimal to 8-bit binary. And I also say that commas separate the attributes here, or the arguments that we're passing in, and we're going to set the width of this to 600. Now again, it's not 600 pixels. Oops, what have I done? So the width is 600 and the height is 150. And we want to give it some padding, and it's called pad X and pad Y. So pad X, and that means inside this frame there is going to be some padding between the border of the frame and the contents of the frame. And the padding, we're going to set it to be 10, so the equivalent of 10 characters, the width of 10 characters, and we'll do the same for pad Y. Now that's going off screen a wee bit, so what you can do with this, you can just hit enter after a comma and it'll automatically display itself correctly so that the program will be able to read it. We'll test it in a minute to make sure that's true. So we're on pad Y this time, that's short for padding on the Y axis, and we'll just set it to 10. Now let's set the foreground and background colours for this, and it's FG is the property that we're setting, and we're going to set it to a hexadecimal colour, and I'm just going for the colours that you saw in the demo there. So it's 8CFF66, so 8CFF66, finish your speech mark. And also I want to set the background colour. Now the foreground colour is for the text, so that will be the colour of the title. The background colour will be the actual background to this whole frame, and again we'll use hexadecimal, hashtag 006699, so hashtag 006699. Finish the speech mark. Right, now you would think and let's just do this, Control S, you would think at this point you would actually be able to see it, but although we've defined a frame 1 and we've given it some property values, what we've not done is added it to this window. And there's two ways that you can do that in Tkinter. You can either use the .pack or you can use the grid. And I'm going to use grid because you've got more control with grid. So frame 1 dot grid, and inside these brackets we're going to put the positioning with a grid reference. So the grid is a row and a column. So this is the first row, so row 0, and it's the first column, so it's column is 0. And I'm actually going to put padding round the frame within the window, so that will be pad X, this time it will be 50, and pad Y, and we'll set that to be 30. Right, now we should be able to see it. So let's save that and then run it. And there we have our first frame. So the 600 width is here, the 150 is here. The background colour, this BG, is this colour here, 006699, and the foreground colour is the colour of this text. If you don't like those colours, you just change it for whatever you want. Now the padding that we've given to it as we've added it to the actual window, this pad X of 50, this is what this is, and the pad Y of 30 is this. So if we take this pad Y off, it should move up to this corner. So let's just check that and see if it does do that. So let's set that to be 0 and set that to be 0 for a wee second, and then run it again and see what happens. So you can see that now that we've removed those and we've set them to 0, we're right up against the left hand edge, the X on the X axis, and we're right up against the Y. So what you can tell from this is that the coordinate 0, 0 is, as usual, up on the left top. So not really as nice looking, isn't it? It's not balanced. So what we'll do is put that back in. So that was 50 and 30. And then let's just check to make sure that's working before we move on. And we're back to normal. Yep, good. Right, so let's put in the bottom frame so that we've got two frames, and then we'll see about the background colour of the window, because I'm not too keen on that colour there. It doesn't excite me in any way. So the great thing about this is I'm just going to copy this. I don't see why I should have to write that out again. So Control C to copy it, and Control V. What I will have to do is give it a different name. So we'll call this frame 2, and we'll call the variable frame 2. So it's frame 2, and we want to change the, well, we can have it looking exactly the same at the moment. Let's just check it to see if that's worked. Now, it has worked, but because it's got the same grid, row 0 and column 1, they're actually sitting on top of each other. So what we need to do for this second frame is we need to bring it down to its own row, into row 1, but the column is the same. We want it to be column 0. So we need to change this frame 2 in the grid to be row 1. Then save it and run it. And this time it should work for you. So this is row 0 and row 1. And we're still in the first column. So now we can use the grid when we're adding objects inside frames. We can use the grid inside this frame. So row 0 will be up here and column 1 will be here. Good. Let's now set the background colour. So we'll close that and we'll set the background colour of the actual window. Now to do that, we'll go back up to this where we've got our basic root properties, and we'll say root, and this time it's configure. So we're using this root.configure, and inside the brackets you're saying which property it is that you're wanting to configure, and you have to say bg is assigned, and in speech marks we're going to put a hexadecimal value for this, and it's hashtag FFFFB3. So hashtag FFFFB3. Let's save it and see if that has been picked up. There we are, that looks fab to me. Now I want this to be a different colour, and I want to change the text for that before we move on. So let's do that. So we're in this frame 2, I need to close that so that I can work on it. We're in this frame 2, and this time instead of the label saying decimal to 8-bit binary, it's 8-bit binary to decimal. And I want to change the background colour really of this, and I want to change it to hashtag 669999. So hashtag 6, get rid of those 2 there, 9999. Let's save it and run it and see if it's picked that up. So there we have, we're getting there. So we've set up our window, we've called it root, and inside of root we have managed to instantiate, create 2 frame objects, and we've called them frame 1 and frame 2. We've given them different titles, and we have given them different background properties. You'll see that the text, it's the default text at the moment, and if you remember back to the example, I had changed the font to make it a bit more user friendly. We'll leave it at that at the moment, and we'll deal with that a bit later. We're ready now to look more closely at the design of the user interface widgets that make up each frame. And remember I said earlier on that we're using the dot grid. I'm just going to use red for this. We're using the dot grid, and I'll look at this one here. So the grid is made up of rows and columns. So this is like a classic grid, isn't it? Where we've got row, 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 and column, column, column. So this would be row and column 0. So that would be 0, 0. This would be row 0, column 1. This would be row 0, column 2. This would be row 1, column 0, row 1, column 1, row 1, column 2. Yeah? And this would be row 2, column 0, row 2, column 1, and row 2, column 2. So that's what we're talking about here. And inside a frame, we've got a grid. Now I know it looks as if 8-bit binary to decimal is taking up the first row, but it's not, because that's a property of the frame. So we've actually only got, if I put that in there, we've actually only got 1 row in this frame, but what we do have is columns. So this is row 0 and column 0, column 1, column 2, column 3, and column 4. So sometimes when we've been working with HTML, we've been able to be very precise and give an X and Y coordinate of the objects that we want to display on the screen. But here we're at the mercy of this row and column setup, and as you'll find out as we go into this, sometimes the results can be a wee bit unreliable and not quite what you're expecting, and you have to add a bit more instructions to instruct Python on how to handle the objects that you're placing in this grid system. Okay, let's go and do that now. Let's go ahead now and add the widgets to our frame 1. So give us some space. We'll move frame 2 down, and we'll start with the label, which is in row 0, column 0. So put a comment in to say what it is we're adding. So this is define the label widget, and we'll call it LBL decimal, and we'll assign it the class label. Remember, capital L, because it's a class. Now, by using these brackets, we're calling the init method, which is the constructor method for this label, and the parameters that we're passing in here, the arguments that we're passing in, will set some of the properties for this object, LBL decimal. So first thing is always the parent, and in this case the parent is frame 1. And then we want to put in some text, and we're going to say decimal, colon, remember to use your comma between. Then we'll put some pad X in, we'll just say 5, and pad Y, 5 for that. And then we'll put in the background colour, and we'll use hexadecimal for this, so it's hashtag 006699. And we'll put in the foreground, FG for foreground, and this one will be hashtag FF9900, so hashtag FF9900. Remember, when you're using hexadecimal for colour codes, it's that although there is 6 digits here, the first 2 digits represent the red colour code, which is from 0 to 255, because it can be represented in 8 bits. The second 2 digits represent green, and the third 2 can represent blue. Right, now we've created it, we've defined it, now we need to add it to the actual interface, and we do that, as you can remember. So add to interface. The way we do that is using the .grid, isn't it? So we've created our object LBL decimal, which means we can now call one of its methods, which is grid, using the dot notation. So LBL decimal dot grid, and we can pass into this some of the arguments that we want. So what do we want for this one? We want to tell it what row to go to, what column to go to. So row is 0, and in this instance column is also 0. And we're going to use a new one called sticky. And what sticky does, and we'll put E in here for this, sticky tells it to go to it orientates it to the space within the grid. So you've got north, south, east and west. So we're going east, so that it's, because this is a label and we want it to be close to the entry box that we're about to create next. Okay, let's save that and run it. So Control S, and then I'm just going to use that. Now, perhaps not what you were expecting. It has created the label inside frame 1, so that is correct. It has given it the colour code, it is the correct text, but it has altered the look of the frame, and that's to be expected with Tkinter. That's what happens. So don't worry about it until you are finished adding the widgets that you want into frame 1, and then we'll see what happens after that. So let's move on. Right, so let's now create the entry box to go along with this label. So let's put in a comment, and we'll say define text entry widget, and let's get the constructor sorted out for this. So we're going to assign it to a variable called ent decimal. So that's given us a bit of information, isn't it? The ent tells it's an entry widget, so it's from the class entry, and decimal is telling us that we're using it for the user to enter decimal. We're using the assignment operator, and next what comes is the class constructor. So we need a capital E for this. Entry is the class, The brackets are calling the constructor method of that class, and inside it what we want to do is put in the properties that we want to set. So we're passing in the arguments frame1 because the parent is the frame1 frame. Then we want to put in the width of it, which is 3 characters, and I think that will do us just now. We'll come back. There are other things that we want to add into this, but we'll do that later. Remember I was talking about the validation earlier on, so we do want to validate the user when they're putting in their numbers. Now we're only allowing 3 characters because remember that this is going to be display a decimal number that can be represented with 8 binary digits, and the range for that is from 0 to 255. Right, so now that we've defined it, we need to add it. So we'll put a comment in here to say add entry widget to interface. So ent decimal dot grid. So we're calling the grid method of the object, and what we're passing in here is the row, which is 0, the column, which in this instance is column 1. We're going to give it some pad x, we'll give it 10, and pad y of 10, and a sticky. This time we're going to orientate it to the west so that it's closer to the label. So let's save that and run it and check it out. So there it is. So we've got our label, and now we've added our widget, and we can see that we can put in here 3 characters. It's only allowing us to put in 3 characters, so all is well. What we haven't done to it is we haven't set a maximum, so it's allowing us to go above 255. We'll need to input validate it, and we'll do that later on once we get the actual widgets into this frame. Let's add the button now to this frame. So put a comment in to say define button widget, and let's actually define it. So we'll prefix it with btn, and then we'll call it convert. So the button's going to be called btn convert. We need to instantiate it, we need to create it. So we're calling the class button, so button with a capital B, constructor, using those brackets, and inside it we're going to set up some basic properties. So first thing is the parent object, which in this instance is frame1. Then we want to set its text to convert. Then we want to set its background property to hashtag 66FFFF, and set its foreground property to hashtag B366FF. And now we want to, now that we've created it or instantiated it, we now want to add it to the frame. So btn convert dot grid, and it will be row 0, and this time the column will be column 2, and we want to give it some pad x of 10 and pad y of 10. Then we'll save it, run it, and see what happens. So that looks okay, doesn't it? We've now got our label, our entry box, and our convert, and we can see the padding between and the padding above and below. So that's all working nicely. Right, what comes after the button? Next thing we want to add is the label for the binary. So define label for binary. So LBL binary, and that's going to be an instance of the label class. So we need to call the label constructor, and as we know, we need to pass in the parent, so it's going to be frame1, and the text for this label will be binary, and we'll give it some pad x of 5 and pad y of 5, and we'll give it a background color of hashtag 006699, and we'll give it a foreground color of hashtag FFFF00. Right, now we want to add it to the grid, so we'll see LBL binary dot grid, and it's going to be row 0, and this time it will be column 3. And we want to give it a sticky orientation of east because it's been used as a label. Right, let's save that and run it just to check that it's been added, and there we are, quite nice. Next, what we want to add is the label to contain the output from our processing. So again, we'll define label, for binary output, and we'll say read only, which is why it's a label and not a text box. So LBL, and this time it will be binary. Now we could say output, but I'm going to say number. And we want to call the constructor, so it's label, and it's going into frame 1. The text that we're going to put in it is just like placeholder text, and it's 8 zeros, 1, 2, 3, 4, 5, 6, 7, 8, because we want to have place for 8 digits. We're going to put some padding on the x-axis of 5 and padding on the y-axis of 5, and we want a background colour of, we'll just say white, so hashtag FFFFFF, and we'll give the foreground, the actual characters, we want them to be black, so that's hashtag 000000, and now we want to add it to the label, so we'll call the grid method, and we want it to go to row 0 and column 4, and we want a sticky of west. Right, let's save that and run it. Yeah, that looks good. Now that we've got that working, the next thing we want to do is define a function to be called when someone clicks on this convert button. So to do that, we need to go up to the top of our program. So I'm talking about just under your import statements for your modules, but before the definition starts for the actual interface. So I'm clicking on line 4, and I'm going to hit enter a few times. So we're going to define a function which will be called when the user clicks on the convert button. So def is the keyword Python uses to define a function, and we're going to call our function dec to bin, and we're not going to pass any parameters into it, and we need our colon. Now when you hit enter, you'll see that you're indented inside it. So just as normal, we'll use our variable base and we'll set it to 2, and this time number, instead of the user inputting it, we're going to input it from the entry widget. So it's ENT, we called our entry widget ENT decimal, and we're going to call the get method of that object, and it will return whatever value has been typed into that entry box. Now, because it is a text widget, this is coming in as text, and we now need to cast it as an integer before it gets stored in this number variable. So we need to use that int. And if you refer back to your previous program, you'll see that that's there. What comes next? Converted number, and this is going to store the output, and we are storing this as text, and our exponent, which we'll set up to be 0, and our original num, which is number. And again, we need that. We'll use that for our print statement, and we will use it for the print statement just now, just to check it. Now, we're not using input validation as such, but we are going to just start into the processing. So while base to the power exponent is less than or equal to number, yeah, and that's the number the user's just typed in. Remember, it will be between 0 and 255. Then exponent is equal to exponent plus 1, and that's us getting our place values. We're using that to get our place values so that we can then iterate. So let's put in our comment, iterate exact number of times, and we can do that because we've just created that exponent to help us with that. So for I in range exponent, and we're going backwards, so the range is from exponent back to 0, and we're doing it in increments of -1. So that's the minus is telling Python to go backwards. Now this loop, the purpose of this loop is to test to see if a place value can be used in constructing the binary equivalent. So what we're saying is if number is greater than or equal to, and then we're doing a calculation here, so we'll do it inside brackets, and the calculation is base to the power exponent, and it's exponent -1, so we'll put that in brackets as well to ensure that the brackets are evaluated first. -1. Then what we want to do, so if we can use that place value, we're going to add 1 to our converted number, and the 1 will represent the place value that's been used. And then what we have to do is subtract the place value from the number. So converted number is assigned converted number, and because converted number, if you look at line 10 there, you'll see it's been defined as string. What we're going to use is the string concatenation symbol, and we're going to add on to the string that's already there in converted number the string 1, the character 1. And then we need to update the value that's stored in number by removing the place value. So number minus, and we're doing a calculation here, so we'll put brackets in, and it's base to the power exponent, and that will remove that from there. I need to make sure it's exponent -1, so I need another set of brackets. Okay, so that's the exact same as the program you have created before. Now, if the number is not bigger than or equal to the place value, then we can't include it. So that means that we are converted number is being updated, but this time it's a 0 that's been added to it, because converted number is actually the binary equivalent. Good. So the last thing we need to do, but it's not inside the selection statement, but it is still inside the for loop, we need to subtract 1 from the exponent. So we're updating the value stored in exponent by subtracting 1 from exponent. Okay, now we want to make sure we display the binary equivalent in 8 bits, because we've said that in the label. So we need to find out how many leading zeros to add to the number. So say for instance a user had put in 5. Now the binary equivalent of 5 would come out as 101. So that means we need to add 5 leading zeros to that. So to do that, we will use a variable called leading zeros. And we will say 8 minus, and because converted number is a string, we can use the len function on it, and we can say tell us the length, tell us how many characters are in converted number, and then subtract that from 8, and that will tell us how many leading zeros to add on. And then underneath here, all we need to do is update converted number and concatenate those leading zeros to it. So converted number is assigned, and we want to put the zeros on before the value that's in converted number. So at the moment, leading zeros contains a value, an integer. So we want to multiply that number by the character 0, and that will give us the correct. So to show you what I mean here, say we put in here 5 multiplied by, and then we put in the character 0, that will give you your 5 zeros in a string, and that's what we're doing here. So we're doing this inside brackets because we want to make sure this happens first before we concatenate it. So it's leading zeros multiplied by the character 0, and then we want to concatenate that, add it to the converted number string. Good, and that will deal with that. Now let's print it out just to test it, and this is what you've already got in your program. So str, and we want to say original num, and we want to add on to that whatever's inside. We'll say converted to binary is, and we'll add on to that the value that's in converted number. And converted number should have 8 characters in it now. Right, but we also want to update our user interface. So we've got a label called LBL binary number, and we want to change the text that's in there. Remember, we created it with 8 zeros just as placeholders. We now want to update that text value. So to do that, we say LBL binary number. You've got to make sure it's the correct object dot config. Remember, we've used that before when we were changing the window. And we're saying text, the property that we're wanting to reconfigure is text, and we want to change it to converted number. Now, converted number is a string, which is why we don't need speech marks there. So that's us created the function, and now we need to add it or call it. So to do that, we want to go back down here to the button, to this btn converted, and what we want to do is use the command property to assign the command to the correct function. So here we are, frame 1 text convert background foreground, put a comma in after that, and then we need to add command, and we need to tell it what to call when the user clicks the button. So our function is called deck to bin. Now we're not putting the brackets on the end of that. Control S, then run it. So let's put in the number 5, and we know in binary the number 5 is 101, but because we're representing it in 8 bits, hopefully it will come out 0000101. So let's click the convert button, and you'll see 0000101, and our print statement 5 converted to binary is 0000101. So that's all working correctly. But what happens if the user puts in 345 at the moment? Well, it's just going to do it. This will be correct, 101011001, and it's used 1, 2, 3, 4, 5, 6, 7, 8, 9 bits. So you can see that it's just going to, and did you notice the slight change in the size here? So we need to control it to 8 bits. So we need to now validate this to make sure that they can't put in a value which is greater than 255. So if they put in 255, it should get your 8 bits set to 1. And down here in your print statement, it's saying 255 converted to binary is. So our program can go further than 8 bits, but we're just focusing on 8 bits at the moment. So we need to put some validation in here. So here's our ENT decimal entry object, and we're going to add validation to it. So we need to create the validation before we can add it to it. So let's go up. We'll do it above the deck to bin definition, but below our import module statements. So let's define our validation, and we're also def check number in range. We're going to pass into it the number that the user has just clicked. They've just typed it into that text box. As soon as they type it in, it will be checked. So we've got to make sure it's within the range 0 to 255, and it won't allow 256 to be added because that's outside the range of 8 bits. So the first thing that we need to do is check that it is actually a number that's been put in, an alphanumeric digit. And there is a predefined function you can use for that, and it's called isNumeric. And if it is 0 to 9, it will return true. And if it's not 0 to 9, it will return false. So what we want this function to do is we say if false. So if this returns false, so if false is returned, the digit will be removed from the entry box. Now, to the human eye, it will look as if it's not even been added. It happens so quickly. So we say if num, because that's the parameter that we've passed in, dot is numeric, then if that's true, we want to then go forward and find out if it's within the correct range. So we'll say if num in range 0 to 256. Remember, you go 1 over the range that you're wanting to find. Now, because num's coming in, it's coming in as text because entry is a text box. So we're doing a comparison on a number here. So we need to turn this into an integer using the int predefined function. So if that's true, if it is within that range, then we want to return true. And if we return true, that means that digit will be allowed to be entered into that box. Else, if it's not an alphanumeric and it's not within that range, we want to return false. But there is another situation that will occur here that we want to check to see if they've put in empty speech marks, and that will occur if you're removing characters to change your entry. So we have to handle that as well, otherwise Tkinter will get stuck and it won't allow you to enter any values. So elif num is equal to empty speech marks, then return true. Otherwise, else return false. Now, so there's two trues, if it is a numeric and if it is within range, and also if it is empty speech marks, you're going to allow that to be handled correctly, and if it says true, it means it will be allowed, whereas if it's false, it's not going to be allowed. Right, so that's us created our validation for the entry box. Now we need to hook it up to our interface. So you have to inform the program that you have validation. You need to register it before you can then reference it. So let's go down to where we created the root object, and we're going to register this in the root object. Now remember, the root object is the kind of start point, the parent of everything, and that is the Tk object. So we're saying validate, what will we call it? Let's call it validation, and we'll say root.register, and we're going to register this check number in range. Okay, so we have registered that with our user interface. Let's just put a comment in there to say what we've done here. So register the validation rule to get a validation ID. So you've registered the validation rule with the interface, and the root object, the Tk object, is giving you an ID which you can then use. So now we can go down to our entry. I'm on line 64 here, my ENT decimal, and I can add two validation things here. First of all, I want to say what I want to validate, and I want to validate a key entry. So put a comma in there and say validate, and it's a key, and it has to go in speech marks. And next what I want to do is call the validation function that I've just created. So we need to use validate command for that. So validate command is equal to, and we put in brackets here what it is. It's equal to, now we've called it validation, remember? Here we registered it as validation, and validation knows to call check number in range. So all we need to write down is validation, and then what it is we want to have passed. So validation, and also we want to pass in, now this is a special character, a special symbol that Tkinter uses to get the value that's currently been stored in the entry box. So it's %P inside speech marks. That's what we're going to pass. So we're calling this validation, and we're passing into it the value that's in this ENT decimal. Right, so let's run that. Let's save it and run it and see what happens. So we've got, let's put in something that we know should be accepted. Let's say 23 and convert it. And we're getting down here because we've still got this print statement working. 23 converted to the binary is 0001011. So that's 16 plus a 4 plus a 2 plus a 1, so that's 23, so we know that's working, and we are getting our 8. Right, so let's put in, now let's back to get rid of that, and it is working, so we know that empty speech marks part's working. Let's try and put in 256. So you should find, if you're working along with this, that when you put the 6 in, it's as if it's not even going in, but it's so fast, it's going in and it's being rejected. So we can put in 255, yep, it'll allow that. When we press convert, we get our full 8 bits. So we've now validated this box. Now let's check that is numeric. What happens if we try and put an A in? Well, I'm pressing A, B, C, nothing, I can't get it in, but I can put in digits. There we go. Right, so that's successful. Right, next what we want to do is put in the objects to the next frame. So now that we've done all this hard work with frame 1, why don't we just copy and paste. So let's take from, I'm taking from line 59 here, I'm just going to copy that, and then I'm going to paste it underneath the frame. So I'm down here at line 88, just give me some space and paste that in. So we should have, now obviously we can't have two objects in the same interface with the same name, so we'll have to change these, but that's okay because they do different things. So we're going to call, we've got an LBL binary up here. So this LBL that we've got for decimal underneath as the first object in our frame 2, we'll call that binary, but we'll call it LBL binary 2. And we want the text inside it to say binary, not decimal. We can keep the same padding, but we want to change the colours. Let's change the background colour here to be hashtag 669999, and let's change the foreground colour to be hashtag FFFF00, and let's add it to the grid, so it's LBL binary 2 dot grid, and it's going into row 0, column 0, and it's still sticky east. So that's that one done. And now we're at the entry box, so we can't call it ENT decimal, so this time we'll call it ENT binary. And we'll change it down here as well, ENT binary dot grid. And one thing that I haven't changed for this LBL binary 2, it's going into the parent is frame 2 this time, not frame 1, so let's make sure we change that. In fact, I'm just going to go through them all here and change it to frame 2, because that would be a biggie. Alright, so that's that done, don't need to worry about that now. So we're in this entry box, we've called it ENT binary, we've put it in frame 2. This time it's not going to have a width of 3, it's going to have a width of 8 for our 8 binary digits. We are going to validate it on the key, and the validation command, it's not the same validation, so we'll make a new one in a wee minute. But we'll call it validation 2 just now, but we are going to pass in the value, so we can leave that the way it is. ENT binary.grid, it's the same position, row 0, column 1, we'll give it the same padding, and we'll give it the same sticky, so that's fine for that. Next one, the convert button, so it's BTN convert, we'll make that convert 2, so that it's not the same name, and it's going into frame 2, the text says convert, the background will stay the same, the foreground will stay the same, but the command this time, instead of decimal to binary, and we've still to make this function, but we'll call it binary to decimal. And row 0, column 2, and the padding is the same, so that's okay for that. Next, it's our output label, so this time it's coming out as decimal, so that will be LBL decimal. And because we've already got one of those up above, we'll call it decimal 2. So let's go down here and change this name. So LBL decimal 2. And it's going into frame 2. The text will be decimal. It's going to have padding 5 on the X and Y. The background colour will be 669999 and the foreground colour will be FF9900. And it's going to position row 0, column 3, and it's sticky east, so that's correct. Last one, LBL binary number. So this is decimal number. So let's put in decimal here. We'll put a 2 in there. So it's decimal 2 number, and LBL decimal 2 underscore number. So it's going into frame 2. The text will be 3, won't it? Because we can only allow up to 255 to be written here. Padding X and Y will remain at 5, and the background will be white and the foreground will be black, so that doesn't change. The row position doesn't change, so it's row 0, column 4, and the sticky will be west. Before we run this, if I run this right now, we'll get an error because I haven't defined bin to deck. So let's go up here and just loosely define it so that we don't get an error. So underneath this deck to bin, we'll put in a definition. So this time it's, instead of decimal to binary, it's binary to decimal. And because we've not got any content for this function yet, we'll just put in a pass. Okay, so as well as this bin to deck definition, we also need to define our validation. So let's add in validation 2, and we'll say root.register, and the validation function that we will create up above will be called check as binary number. Alright, so that should cause it not to. So up here, because we have said we're going to call this function, we'll need to create that function. So we'll put it up here, so we've got def check number in range. So we'll say up here def, and this time we're saying check is binary number. We want to pass into it the character that we're going to check, but we're not defining it just now. We just want to get this running to see if it's working okay. So Control S to save that, F5. So we should have both of our frames. We've got one that says decimal to binary, and we've got one that says binary to decimal. We've got our 3 digits at the end here. That's all looking good. So I want to be able to put in 101. And that's okay because we've not actually hooked up this convert button, but I can put 101 in there. But at the moment I can also put in alphanumeric characters, which is really annoying. So we're going to have to validate this to make sure that it is only 1s and 0s that are allowed in there. So that's what we'll do next. So we'll validate it in this check as binary number. And this is where we're going to use the regular expressions. So what we'll say is pattern. So regular expressions are used to match character patterns, and they're used a lot for validating emails and telephone numbers and things like that to make sure that the user input matches. And in this instance, we want to match that it is a 0 or a 1. So we're going to be validating it on the key press. So when they press a 0, we'll be matching it, and when they press a 1, we'll immediately match it. If it doesn't match, it will be immediately removed from the text box, the entry box. So what we say here is, now up at the top, we create import RE. So we're using this RE, which is the regular expression module dot compile. So this is a function from the RE module. We are going to tell it what to compile. We're going to give it a rule, a pattern match rule. So this is how you would write this down. It has to happen inside speech marks in Tkinter. The caret is used as the start of the expression, and the $sign is used as the end of the expression. So you're wanting to click in between those two symbols, and what you've got in here is what's to be matched. So we want to say inside these square brackets that we're going to allow characters between 0 and 1. That's all we're going to allow. And then what we're going to say is, outside those square brackets, is that in curly brackets we're going to put the range, the number that we're going to allow. So the max number we're going to have is 8, isn't it? So between 0 and 8, that's all we're going to allow in there. And that's it. That should work for us. So now what we want to do is we want to click on return, and we're going to return true or false. So pattern dot match, and we're using this char, which is up here. This is what we've passed in, so it's the key press. Whatever value was put in as at the last key press, we're putting in there. And if it is not none, that's a strange way of writing it, but what that means is if a match was found, it won't be none, so that means true. So it'll return true, otherwise it'll return false. So now what we want to do is come down to our where we registered, and we've got that in there, okay. And what else? Yeah, we've got it into our frame 2, we've put in our button. And we've put into our ENT binary, we've got our validate command validation 2, and it's on P. So let's test this validation to see if it's working. So when we try and put in a character like W, nothing will happen. When we put in a 1, we're allowed. When we put in a 0, we're allowed. But when we try and put in a 2 or a 3 or an H, any other character, it's not going to allow. And it's going to allow 1, 2, 3, 4, 5, 6, 7, 8. It is going to allow the full 8. So that validation is working on that. We've got input validation. We're controlling what the user can do here. We've still not hooked up the convert button, so it's not actually converting it, but that's what we're going to do next. So let's add the code now to our bin to deck function. So here's our bin to deck. We'll get rid of pass and we'll start to code it now again. This is the same code that you have previously done. So let's create a couple of variables here. So binary num will be what the user has inputted into the entry box, and our entry box is called ENT_binary. And we're doing a .get on that. Now it's coming in as text, and we're going to leave it as text because we're going to iterate through each character in that string to find the place value of it. Remember, we have to reverse it. So we need a variable called reversed binary num. And we're going to assign it an empty string, and we'll use it later on. Again, we're using base 2. And we need a variable to act as a running total. So we're going to call it running decimal. So this code sequence follows the kind of algorithm for a running total, because it's iterating over a data structure, an array, and it's adding the values. And what else do we need? We need an array, so R, and we'll call it binary, so R binary, and we'll set it up to be an empty array to begin with. And then what we want to do is we want to reverse the user input. The reason that we've got to reverse it is because we're using the 0 position of the array index as the first exponent. So reversed binary num is assigned, and binary num, and then how to reverse it is put in the range and then say reverse, and reverse one step at a time. Now just to check this, to make it sure it works, what we could do in here is put a string in that says, let's say Monday, and then we could say square bracket -1, and it reverses it. So this is what this code is doing, it's reversing the string place values. Right, and we're using it for that reason as well. What we need to do next is iterate over the string, convert each string character to an integer, and then append it into our array. So let's do that. For index in range, and inside this range what we're going to do is count the length of the reversed binary num as our range, and then what we're going to do is r binary dot append, and inside this append function what we're going to do is we're going to turn it into an int, so we'll use int and put inside here what it is we want the value. So it's reversed binary num position index. Right, so this is our index here, and we're using that to locate each character in the reversed binary num string. So after we have our array populated, the next thing we want to do is iterate over the array, calculate the place value and add it to our running total, and that should give us our decimal total at the end. So for index in range, and this time it's len, and it's over r binary, and we're using this running decimal, and what we're going to do is assign to it what's already in running decimal, and that's what makes it a running total, because you're assigning the value that's already in it plus whatever we're about to calculate. And what we're about to calculate, we'll put in these brackets because we want the brackets to be evaluated before that addition. And what we're going to do is say r binary position index, okay, multiplied by base to the power index. Right, so now we're ready for our output. So we're outputting to, in fact let's put a comment in there. So now we're outputting to interface, and we decided that we were going to output to the LBL decimal to number. And we can either, there's two ways that you can do this. You can either do .configure, I think, or you can do it this other way. Let's show you the other way. So you can say text in square brackets like this, and then assign it the value. Now running decimal at the moment is an integer, so we need to cast it as a string. And that should be fine. So let's save that, and let's run this and check to see if it works. So let's put in 101, which we know is 5, and then convert it, and we've got 5 there. See how this has changed shape and size? Let's put in a bigger number. Let's put in 1000, which we know is 124 is 8. So let's convert that. We've got 8. Let's put in 16, so it's 10000. 16. Do you see how it all moved? We'll need to deal with that. And let's put in 255. So it's 1 2 3 4 5 6 7 8. Convert, and that should be our maximum. 255. Good. So if I put 255 in up here and convert, we get this. Let's put in another number. So 34, and then let's put it in here and check it. So 00100010, convert it, and we're getting 34. So we're kind of testing, and we know that that is correct. Good. So the next thing we want to do is format the fonts to make the user interface look a bit more appealing than it is right now. So I'm going to define them under my validation before I go into my frames. So I'll put a bit of space in here and then put a comment in just to see what's happening in this section. So it's define font styles, and then I'm going to create a couple of styles. So my frame labels, I want them to, remember at the top here we said when we were bringing in the modules, we said import tkinter.font as font. So I'm going to refer to the fonts module as font now, and I can use the dot notation for that. So what I can say here is font dot font with a capital F, because I'm declaring what's the word? So we'll call our first font frame labels. And I'm referring to remember at the top here, when I imported the font module, I said call it font. So I'm just going to refer to that now. So font dot, now capital F font, because this is a constructor for a font. And inside, this is you calling the constructor when you put on those two brackets. And inside here we say I want a font, create a font which is size 20, and also make it the font family. Now I want to use Apple Boy BTN, but you can use whatever font you want. I'm also going to create a font called num labels, and again it's font dot capital F for font as the constructor, and the size of the number labels will be size 15, comma, and the family will be Apple Boy BTN. Now I'm going to create another one for digits, and that will be the digits inside the output labels. So we'll say font dot capital F for the font constructor, and this time the size will be 15. The font family this time will be Bohos 93, and one more, and this one will be for the buttons. And so font dot font size 10, and the family will be Action Man. Now if you don't have these fonts on your computer, you might have to change it to a font that you do have to see this working correctly. But these are the ones I like. Right now, this is us defined them, but we've not actually applied them to any of our widgets yet in our user interface. So let's go and do that now. So let's go down to the widgets and we'll go below the widgets. And what we're doing here is, so right down below frame 2, but make sure it's before this root main loop. That's to be the last thing in your program. So we're now going to format the styles. So we defined the styles, but now we're going to format the widgets with the font styles defined above. Just right, so the first one we're going to say frame 1 and we'll put in those square brackets, single speech mark, font is assigned frame labels. Frame labels is the, make sure you've got the spelling exactly correct as the defined font up above. And what we've said here for frame 1, the font, so remember this will be the label on frame 1, and we also need to do the same for frame 2. So frame 2, font is assigned frame labels. We're able to reuse that defined font and it will give us a bit of consistency in our user interface. Right, now LBL decimal font is going to be num labels. And I'm going to copy this, paste it underneath, and the next one we want is decimal 2 to be the same, and then I'm going to paste it again, and this time it's binary 2, and one more time. In fact, I think I'll just copy that one. Oops. And binary. So that's the labels dealt with. Next one we want is our number. So this is LBL decimal 2 number. And we want the font of this to be the same as digits. So I'll copy this because we've got a couple to be like this. So copy, paste it underneath. And the next one is, instead of decimal 2 number, we'll say binary number. And we'll do the same for the ENTs. So Control V that in there, and we'll say ENT. So this is the entry boxes, we'll say ENT binary. And the next one is ENT decimal. Right, and we've got 2 more for our buttons. So I'm just going to paste that in. And this one's BTN convert. And this convert is, I'm going to copy that, paste it underneath, and this will be convert to, and that's buttons. Let's save it, see what this looks like. That's looking a bit better, isn't it? So what we've done here is, our frames, we've set the font labels up, so they've got the size 20 with the apple boy. The labels for decimal and binary, so these here, decimal, binary, binary and decimal, those have been set up. And in the digits, we've put in this bohos. Right, and the buttons have been action manned. That's looking good. So let's see if these have been set up. So 255, yep, and we'll convert it. And let's put in here 11111111. Convert it to 255. So that's looking good. So 1 2 3 4 1 2 3 4 15. Right, that looks good. And if I put 15 up here, does that look the same? Yeah, 0 0 0. So that's looking good. There's something else that I want to do, and I want to add, let's run that again. Now, there is no cursor flashing to inform the user of where to start, or to let them know that this is a text box that you can actually put text into. So we need to give them that flashing cursor. And also the order that you do things, you might want them to start here and then move down here. So what you could do is, after this convert button has fired, you could add a bit of code to force this to be flashing. So let's do that next. So we want to go up to our, right up here to our first frame, and into our first ENT decimal entry. Let's just put it under here. So we're still going to say ENT decimal dot focus, and let's put a comment in there and just say set the focus, and that is a flashing cursor. Let's check that works. Control S, F5. So now we've got our flashing cursor, so that's been a bit more user friendly. You're directing, or if the user just starts typing, as long as it's a number they type, that should go in nicely. Okay, now next thing, once that's happened, it would be nice if it moved from there down to here. So let's do that next, and where we have to do it is we have to do it in the actual function, and it's the function called deck to bin. It's the last thing that we want to add there. So deck to bin, so this is decimal to binary. After it's displayed the answer onto the label binary number, what we want to do here is set the focus. So this time it will be ENT binary dot focus. Right, so let's save that and then run it again, check to see if that works. So we'll put a number in here, let's say 198, and now we've got our flashing cursor here. And let's just check to see if this is correct. So it's 11000110198, so it's all working nicely. Now, the size of this frame is actually just the size of the contents. It's not actually the size that we defined it to be, so we want to go and fix that next, because see how these are not even? Right, so let's do that next. So we go down to frame, where we defined it, and after the frame1.grid, what we can do is frame1.grid underscore propagate, and you want to set this to false, and that will instruct the interface not to resize no matter what happens to the widgets contained inside it. Right, so you can see how this one now is actually occupying the size we defined it as, whereas this one underneath, frame 2, is only occupying the size of that the widgets are. So let's fix that. So we'll copy this code and we'll put it for frame 2. So let's go down to frame 2 and change this to say frame 2, and then save it, run it, and that looks better, doesn't it? We've got a bit of balance here, nice size, everything's laid out nicely, and let's check it still works, and let's check that's working. So 0 0 0 0 1 1 0 0, and that should be 12. Yep, everything's working nicely. Good.